Welcome to today's tutorial. We'll look at when to apply multiple linear regression. So if you are a graduate student or an undergraduate or any career researcher who is interested in the use of multiple linear regression for the study you are conceptualizing, this tutorial will be of help to you, and I encourage you to watch the tutorial to the end so you'll be able to learn more about when to apply multiple linear regression in your study. So here is the overview of multiple linear regression. So when you look at the first conceptual model here, you will see that I have only two variables, variable x and variable y. So this clearly demonstrates that we have only one linear line. So we want to find out the effect of variable x on variable y. In this case, variable y is my dependent variable. The variable x is my independent variable. So this also means that my variable y is the problem of my study, and the variable x is the effect I am bringing. So the arrow shows you the effect I am bringing to see how it can change variable y. Okay, so this is the problem of the study. So this is the variable of focus. In most cases, it is also called outcome variable, while the variable x is also called predictor variable. Now, when we go to the second conceptual model, you will see that I have more than one independent variable. So I have x1, x2, x3, and it can be up to x10. If you have 10 independent variables, you can add into the research model. But the rule of the thumb is that the dependent variable must be one continuous variable. So multiple regression is a statistical technique used to understand the relationship between one dependent variable and two or more independent variables. So here are the key conditions for applying multiple regression. Number one, there must be presence of multiple predictors, just like I showed previously. We have x1, x2, x3, it could be up to x5, x6, x7. That is independent variables 1, 2, 3, 4, and 5 or more. So the independent variable is also known as predictors. Number two is that the variables in your study must be continuous. So the independent variables and the dependent variable must be in continuous format. An example of a continuous variable can be students' test score, people's height or weight or temperature. So these are variables that are in continuous terms. However, you can also convert Likert scale data, which are measured using rating scales, into continuous variable. So you can check out my video down the video description box to see how you can convert or group Likert scale data into continuous variable. Number three is exploring complex relationships. So in this case, the combination of multiple independent variables and one dependent variable gives you the idea about exploring complex relationships. So in this case, all the relationships are meant to be tested simultaneously. Number four, controlling for confounding variables, or what we call control variables. So these variables could be like demographics, such as the age, gender, educational level, income level, etc. So you can use these control or confounding variables to suppress the effect of the independent variable on the dependent variable. So the confounding variables are mostly not part of your hypothesis, they're not part of focus of discussions in your finding sections, but you use them to reduce possible multicollinearity in your statistical results. The next one is modeling interaction effects. So if you want to have moderation effects, interaction effects, multiple linear regression can help you to do this, because the moderator variable will be able to interact with the independent variables to affect or influence the dependent variable. So multiple linear regression can enable you to achieve this. Data collection using item statement. You can use Likert scale, rating scales for data collection and then transform the data into continuous, so you'll be able to run the multiple linear regression analysis. Now, examples on when to use multiple linear regression. Number one, suppose you are studying the impact of education level, work experience, and age on salary. In this case, you notice that salary here becomes the dependent variable because we want to see the effect of educational level, work experience, and age on individual's salary. So the multiple regression helps you to determine how each factor affects salary. So these factors refer to education level, work experience, and age, while holding each other constant. Another example could be in health research, where you want to explore how diet, exercise, and sleep patterns collectively influence individuals' blood pressure. So you can see that in this case, the blood pressure becomes the dependent variable because that is the variable of focus, while diet, exercise, and sleep pattern are independent variables predicting blood pressure. So here are common misapplications of multiple linear regression. Number one, ensure you do not use multiple linear regression if your predictors are highly correlated with each other. This can lead to multicollinearity issues. What do I mean by high correlation? So one way to test this is you can do Pearson correlation to be sure that the variables in your study are not correlating above 0.7. Some theories suggest 0.7 and above, others say 0.8, others say 0.9. Once it's about 0.9, then that is a serious correlation, meaning that the variables are correlating too much or too high with each other, so you need to keep an eye on that. Number two is don't use multiple regression if your sample size is too small, as this can produce unreliable estimates. Scholars are encouraged to ensure that while collecting data, they at least exceed 200 sample size. I try to encourage my students, due to the stress in collecting data, to go above 150 sample size. So when you have below 100, that can affect the results of your study. So lastly, let us do a recap of what we've done so far. Apply multiple regression when you have multiple predictors and a continuous dependent variable. This is important. When you conceptualize your study and you find out that you have only one problem of focus, which is your dependent variable, and you have multiple proposed solutions you're bringing to change the dependent variable, which in this case is the problem of the study, then multiple linear regression can be applied. Lastly, understanding when to use this powerful tool is the first step in conducting a robust analysis. So if you want your research to be robust, a statistical tool like multiple linear regression can assist you to achieve this. So far, these are the ways you can apply multiple linear regression to your study, and I hope you find this video interesting. Please like the video and share the video, and also subscribe to my channel if you have not. Thank you so much for watching.